Okay, this is going to be a first attempt at recording, so we'll see how it goes. We're going to talk through lesson 1.2 for probability and statistics. We're going to talk about some variables and types of data. All right, so the first thing we're going to talk about is some quantitative and qualitative variables. So the first type is qualitative variables. Qualitative variables are categorical variables. And if you think about the root word there for qualitative, it would be quality. Okay, so if you think about qualities of things, those are like hair color or flavor of ice cream, anything basically that is a non-number. Okay, so it is a non-number. I know that's sloppy, but it is a non-number. All right, the next one is a quantitative variable. All right, and quantitative variables, these are going to be, as the root word would say, a quantity or a number. These are numerical measurements or counts. Okay, so these are actually numbers. So anything that can be represented as a number, that's quantitative. Pretty much everything else that isn't a number, that's qualitative. Okay, so you're going to have some questions where you have to decide if it's quantitative or qualitative. Just remember quantity and quality, okay? All right, the next two types are discrete variables, and I know when I taught Algebra 1, we discussed discrete variables a little bit in Algebra 1, and these are values that can be counted. Think back to when you learned how to count as a child. You would start 1, 2, 3, 4. Well, what do you notice about those numbers when you were learning how to count? They were all whole numbers. Okay, so we didn't learn when we were little. We didn't go through and say 1, 1.5, 1 3/4. Okay, so when we're talking discrete variables, we're talking whole numbers. Now, on the flip side, we have continuous variables. Okay, so continuous variables, the definition here is a little bit confusing, but it says that there are an infinite number of values obtained by measuring. Basically, this is all of the decimals and fractions between the whole numbers. So these can include decimals, and fractions. Okay, so they can include decimals and fractions. So what we're going to do on these first examples is we're going to figure out if these are discrete or if they are continuous. So we'll discuss it. All right, so for number 1, the number of children in a household. Okay, so what we want to ask ourselves is this a whole number, or can it be in halves or in fraction form or decimal form? Okay, so you are going to have whole children in your house. If you have half of children in your house, then that would be illegal. Okay, so we have whole children in our house. Since it is a whole number, then that would be a discrete variable. All right, time to respond to a question. Okay, so if you think about it, it could take you a half a second to answer a question. It could take you a whole second, but it doesn't always end in a whole number. So time itself is always continuous. All right, so weight of a firefighter. When we're talking weight of a firefighter, think about when you go to wherever your scale is at home, and majority of the time, they're digital scales nowadays, and when you step on it, it could say something like 150.6. Well, that has a decimal in it, so you don't just have whole pounds when you're talking about weight. So since this can be a decimal or a fraction, then we'll say it is continuous. All right, so the next one, number 4, says we flip a coin and count the number of heads. Okay, so if you flip a coin 4 times, you could have 3 heads and 1 tail. You're never going to have 2.5 heads. It's just not going to happen. The options are heads or tails. So since you can't cut it in half, it has to be a whole number of heads. That's going to be discrete. And the last one here, number of phone calls you receive per day. Now, I've heard in the past, what about drop phone calls? Well, it still counts as a call. Okay, so you get whole phone calls, either missed or received. You get whole phone calls. It's never going to show up missed call 3.5. It's just not going to happen. So whole phone calls, that would be a discrete variable. Okay, so you're also on your test at the end of this chapter and your homework and your classwork, you're going to have some where you have to determine whether the variables are discrete or continuous. All right, the next thing is the first time we get to use numbers in here, yay. So we're going to talk about something called boundaries. Okay, so if we are talking about boundaries, like in life, I usually ask, what do you think of? And a lot of the answers I get are like a fence or something like a gate or something like that. Lots of different answers. Well, a boundary really is it tells you how far you can go in any direction. That's what it is in real life. Okay, so if I'm putting boundaries on a number, then it tells me how far I can go in one direction or the other. Okay, so that's what we're going to do. We're going to bound numbers. We're going to tell it how far it can go in the negative direction or in the positive direction. All right, and so there's a pattern to this. All right, so it has to be a continuous variable because we're going to add a decimal place, and we know continuous is the one that can have a decimal place, and it will always end in the digit 5. Okay, so we'll work through some examples. All right, so if you look at example A, it is 15 centimeters. So what we're going to do is we're going to think through this. We're going to go and figure out what is in front of 15. What number is in front of 15? Well, that's 14. And then we have 15. And the number after 15 would be 16. And if I needed to go in between 14 and 15, I would be at 14.5. If I needed to go between 15 and 16, that would be 15.5. So we added a decimal place, and it ends in 0.5 on both of those. And essentially what we've done is we've bounded to the left, which is 14.5, and to the right. So it can go no lower than 14.5 and no higher than 15.5. All right, there's another way to do this, and I'll show that to you in just a second. But let's talk 86 degrees Fahrenheit. Okay, so we want to go down and up Now for the whole numbers, you can think, okay, I need to go down a half and I need to go up a half. If you think of it that way, you would go 86 down a half would be 85.5. 86 up a half would be 86.5 degrees Fahrenheit. For 43 seconds, it's a little bit different as far as we have some options here. What if we said 42, 43, 44, and then just bounded between? That would give us 42.5 to 43.5 seconds. Now, what happens when we get to D? Well, A, B, and C did not have any decimals in there. Now we have D, and if I ask you what comes in front of 1.6, you might not know exactly what to say. I've heard 1, I've heard 1.5, I've heard lots of different things. So I'm going to teach you a way that will work every time you have decimals. Okay, so what you want to do is you want to add a 0, 1.60. All right, and you want to think of this without the decimal really, as just a regular number. And we're going to go down by 5 and up by 5. Okay, so we have 1.60 here. If I want to go down 5 from 60, where am I? Well, I'm at 55, so I have 1.55. If I want to go up from 60, I'm at 1.65. So we went down 5 from 60 and up 5 from 60 to get the 55 and the 65. And that will always work. Okay, so you might say, well, why do you do it that way for that one and not for the whole numbers? Well, if you look at the right-hand side, look at part E, that's a whole number, 27 feet. Will it work? Well, the thing is, when I added the 0 down here to 1.6 on D, I got 1.60. That is an equivalent statement. It's still 1.6. So is there a way that I can add a 0 to 27 and make it an equivalent statement? Well, if I just add 0, that's 270. That's not my number. But if I put a decimal here, 27.0, yes, that is equivalent. Now, if you think of this as just a number, well, what is below, 5 below 270? Well, that is 265. You keep the decimal in the same place. What is 5 above 270? 27.5, 275. So it does still work for the whole numbers. Sometimes I just think it's easier to think go down a half and up a half. But it really is up to you. Now for the decimals, I suggest always adding the 0. All right, so for F, we have 8.7. I'm going to add a 0. So I've got 70 after that decimal. So I've got 8 point, what's 5 below 70? Well, that would be 65. 8.5 above 70 would be 75. Okay, so here we have 8.65 to 8.75 yards. Okay, so on G, it gets a little more complicated because we have one more decimal place. Doesn't matter because we're going to add the 0. And now we have 1 point. And what is 5 below 340? Well, that's going to be 335. So here we have 1.335 to 1 point, well, was 5 above 340? 345 ounces. Okay, so on your test or quiz or your notes and your classwork, there will be problems where you're going to have to find these boundaries. So just remember, if there's a decimal place, add a 0, down 5, up 5. If it's a whole number, go down by a half and up by a half. Okay, so the next thing are measurement scales. Now these you don't have to memorize. You'll have a chart in your book that you'll be able to look at. All right, and these are different types of words. All right, so this first one here is nominal level. Okay, so these are some non-overlapping categories with no order or ranking. And an example would be a zip code. If you think about our zip code, the only place in the nation that has a zip code 29720 is us. And technically, that would mean that that is a non-overlapping category. And also, no zip code is better than any other. So that means there's no order or ranking. So that's why it's nominal level. Nominal is just a fancy word for normal level. The next one is ordinal. An example of an ordinal level measurement is ranks, like in the military. Okay, so as far as ordinal, what does it mean? It means there is an order to it. Okay, so this could be like first, second, third place. That's a definite order. Poor, fair, excellent. Those are an order. There's a precise order and difference between the ranks. So if it can be ordered, that is going to be ordinal level. On the next page, I'm going to go over to it. I'm going to put this next definition at the top because it's split on your notes page. Okay, so these two go together. Interval level. All right, an interval level, an example of it would be temperature. And I'll explain that further in just a second. Let's get to the next one. It's ratio level. And if you notice, it says that it is same as interval, but with a true 0, which is a very confusing way to say what I'm about to tell you. Okay, so the examples of ratio could be time and salary. Okay, so for interval, it says there ranks with a precise difference between units, however, no meaningful 0. What I want you to remember is interval can go negative. Okay? Ratio cannot go negative. Cannot go negative. Okay, so think about it. It doesn't really happen around here, but can temperature go into the negative degrees? Yes, it can. As far as time and salary for the ratio level, can you go back in time? Well, no, we haven't figured that out yet. So, no, time cannot go negative. What about salary? If I have a salary that is in the negative, then I don't really have a salary. I'm not making any money. Okay, so that is the different levels of measurement. Okay, so at the bottom, if you'll notice, it says chart on page 8 in your books. Okay, so this chart will have all of the different, well, not all of them, but some examples of these levels so that you can answer the questions accordingly. So if you're having trouble with nominal, ordinal, interval, and ratio, check that chart on page 8 and it should answer your questions.